Welcome to another episode of the Data Science Leaders Podcast. I am your host, Dave Cole, and today our guest is Robin Foreman. Robin is the Director of Data Science at CVS Health. Prior to that, she had received her PhD from public health from the University of South Florida. Robin, welcome to the Data Science Leaders Podcast.
Thank you for having me. Just as a quick note, all of my opinions are my own and not necessarily representative of my company, but I'm excited to share them with you.
And that's why you're here, is I want to hear what
Yeah.
you have to say, not what your company has to say, but what do you have to say? And that's going to be probably where we start, because I think the path. So the few topics I want to dive into today, your path from public health to DSL is kind of a unique one and an interesting one, and I want to dive in and hear a bit about that, because I think what's interesting about our various data science leaders is how they become data science leaders. Like you need not always start with a PhD in statistics. Now you have a PhD, but not in statistics. But we'll talk about how how that played a role in what you're doing today. The other thing I think is kind of interesting is you have expertise around data science and clinical trials. We'll dive into a little bit of that. I'm going to get educated on what that means for your world. And then last but not least, we'll talk a bit about product analytics. But before we dive into all of those topics, like CVS is a big place. Can you at least talk to us, like what is CVS Health specifically?
Oh, that is a tough question. So many of you are not aware, CVS has their kind of hands in all aspects of the healthcare system. So we have the pharmacy, which is probably our most recognizable piece of it. CVS recently bought out Aetna health insurance. So some of you may have had our health insurance. And so I came from that side. So we sell health insurance, we do the pharmacy, we do pharmacy benefit management, and continuing to try to expand. I mean, CVS really wants to be a healthcare company and not kind of siloed into these traditional areas. So right now, that's really the goal of the company.
Got it. And then let's dive into your journey into becoming a DSL. So you started out of school, you got your PhD in public health. So what is like, what did you want to be like back in the day when you were getting your PhD? What was your goal? What do you think you'd be doing right now?
I mean, I think it started before my PhD, so I'm going to jump back a little bit.
Okay.
So
All right, great.
I got my bachelor's in mathematics and psychology, which everybody told me was a strange combo, which it probably was. And then after graduating, I actually went on to get my master's in forensic psychology. So I kind of gave up the math aspect of it. And while doing that, I worked as a mental health counselor. So I actually worked with people with serious mental illness. And did that for a few years and just decided direct client care was not what I wanted to do. And so I actually, as part of my master's, I did an internship. And while I was at the internship, my mentor was like, "Hey, Robin, like you seem really good at the research aspect. Have you ever thought about going into public health?" And I was like, "I don't even really know what that is." But he kind of introduced me to someone who was like, it's very heavy statistics. It would bring you back to the math, and it's still trying to improve health. And you can focus on people with mental illness still, but get some of the math back in there.
Yeah.
So that's why I went to get my PhD. And so while working my PhD, my focus was really on the comorbidity, which means people with mental illness and medical conditions, right? So people kind of cross both boundaries. And I got kind of specific within that. So I focused on people who are involved with the criminal justice system and, looking at interventions that could potentially keep people out of the criminal justice system and get them the right kind of care. So
the right kind of when you talk about comorbidities, I assume you're talking though specifically about like mental care, mental health.
Yeah, a lot of it is mental health care. But people with mental health conditions will have years ago I had a client. She had a mental health condition. It was pretty severe, but she also had a history of heart problems in her family. But because of her mental illness, the doctors didn't really ever pay attention to the history of heart problems in her family. And she had a heart attack and died when she was 60. It was, it was just devastating.
Awful.
And it's nobody's fault, right? But it's just the way our system kind of functions. We have silos. So that's kind of what I was focusing on in my PhD is how do you bring these systems back together to really treat people holistically,
Right.
which doesn't at all sound like data science.
Run well, it can. It depends. I mean, I'd imagine that data science can play a role
It
in
does.
helping to treat patients holistically, right, and not just being very very siloed. Like obviously in the medical profession, people specialize, and it's great that they specialize because they can become experts in heart disease and oncology and so on and so forth. And you always want to be working with an expert, but some of these things, I think, what you're saying, that they interplay, like they either could be overlooked, or they can interrelate. And if you don't see the forest from the trees, you don't take a step back, then you're not able to treat the patient in a great way. So,
Yeah. And so
so
for
carry on with
me,
your journey. So sorry for
yeah,
that
so
little
what,
segue.
no, it's great. I'm in my PhD and I was like, hey, I'm taking all the statistics courses as my electives because they're so interesting. Of course, this is where the data science comes in. Um, taking stats courses as electives. But that's where I was like, if I ever want to have like a large scale impact, I want to focus on the quantitative side of things. Like for me, that's where my interest is, it's what I'm good at. And if I really want to fix some of these systematic problems, data science can be that avenue.
Right.
Back then, we didn't call it data science. I think it was still referred to as analytics, but same thing.
Mm-hmm. Great.
So
So you
yeah,
decided that, like, that love of statistics was really the way for you to impact people, many more people than working sort of one on one. So how did you came out with this PhD in public health, and then, like, how did you then get into data science? Like, did you just start as a data scientist, or
yeah, I
um,
got a job working as a data analyst, and then moved into a role that was a little bit more. I think it was called a research analyst. Did that for a couple of years, and then applied to my current company as a senior data scientist is what it was at the time. It was an interesting time. It's when the titles kind of were changing, right?
mhm,
So it used to be like analyst or informatics or things like that. And that was at the point where data science was really coming out as like a job title. And
right.
so the role sounded interesting. It was similar to my background. And so I jumped on it and I've been in data science ever since.
That's great. I mean, I think there are a lot. I see this all the time, right? The data science has become, and data scientist has become quite the job title, quite the buzzword.
Yeah.
And there are a lot of analysts out there who might have more of data visualization expertise or a BI sort of expertise, business intelligence expertise, and they're wanting to move into data scientist. And some of them are going back and getting maybe even degrees or taking courses in statistics and data science to become data scientists. Others are just sort of rebranding. So you happen to have, I imagine, with those electives, a strong foundation in statistics. But is there anything else that
Yeah.
you did, or were you like, hey, this is like right up my alley? Like, it's easy for me to move from data analyst to change my title to be data scientist, because that's basically what I am.
Yeah, it's an interesting question. So, like, I was trained a little bit more classically. So, like, you
Hmm.
would think like traditional statistics and data science nowadays are not trained classically. So, yeah, you still get people with a statistics background, but even that's a little different. So, it's more of a focus on predictive modeling. When I was trained, the focus was more on like inferential models. The difference between them in practice, now they call logistic regression a predictive model, which it is.
Right.
But it used to be an inferential. So, like, there's some overlap there, but some of the more machine learning techniques weren't as popular back then. So, for me, I learned those on the job.
Right.
Um, where now there's this expectation to come into data science, you're already pre-trained in all of this, which I mean, it's forever changing, and I think the field has constantly been changing. And even when I talk to other data scientists, there's things they do that are completely out of my wheelhouse. So
And what are those things more from, like a coding standpoint? I mean, well, before we go there, like, when you say I was more classically trained, like, I assume you mean classically trained as a statistician. So,
yeah,
like,
like I was like
you're more. Go ahead.
doing like means by hand. You had to calculate chi-square by hand and learn how it
Right.
actually worked and do your first linear regression by hand.
Yeah. Whereas
Yeah.
I think, and I don't think it's a slight against maybe somebody who's
No,
trained as a data scientist, but like
no.
what I've seen when I talk to guests is when they talk about sort of the difference between that classical statistician and more of a data scientist is that a little bit more the data science is a little bit more focused on the end result, which is just like I don't care quite how we get, there's a little bit of the ends justify the means, like I don't care what algorithm is the right one as long as the accuracy is as high as possible, as long as we don't overfit and that kind of thing. A statistician really takes a lot of care in figuring out what features are being used and what model is being used and really understands the nature of the data set that they're working with. Is that a fair summarization? I'm not sure if I'm
Yeah,
onto something there.
I do think that's fair. And I think it depends on the organization that you're working for, on which of those skill sets is most important.
Right.
You know, even within my company, there's certain areas where like accuracy is the most important thing. So there's other areas where you're building models and people are going to ask you like what's in it, what features are in it, what is popping up as being important. And so I don't think there's like one way is better than the other. Honestly, I think a combination of those skills makes you the most effective data scientist.
Right. Yeah. I could see both backgrounds being very complementary in a lot of ways
Yeah.
in terms of working together. I think like, one piece of hidden advice coming out of this conversation here is just maybe thinking about that mix, right, of sort of classically trained statisticians become who are now labeled data scientists, and
Yeah.
folks who just came through the data science ranks, maybe came with more of an engineering background with an interest in statistics, et cetera. So I think that's like an interesting combination. So let's talk a little bit about what you're doing now, though. So now,
Okay.
I do want to talk about, it seems like clinical trials and controlled experiments and RCTs. I'll let you fill in that acronym there are a big part of what you do. So talk to us a little bit about what it is that CVS Health does.
Yeah. So my focus and I'll try to keep it kind of broad. So the team that I work on, we really are focused on people who have chronic conditions and how can we help people better manage their chronic conditions so that they stay healthier and stay out of the hospital, you know, which is a tall order.
Right.
But we have programs in place where like we actually employ nurses and they'll reach out to people and try to help them manage their condition by helping them get their medication, talking through any of the treatment plans or anything like that where they might need help. And so historically, a lot of that was based on like, this is who we think we should be talking to. So
Mm-hmm.
it might have just been by diagnosis, like anybody with hypertension, we should talk to them. And over time, as data science has gotten more embedded in some of those clinical processes, we've been able to drive that conversation. And so we went from that very, hey, we're just going to outreach everyone with hypertension, which I will say is not how it actually works, but I'm just
Right.
simplifying.
Sure.
And then they were asking, does it work? Does it do anything? And you're kind of like, well, it's hard to tell. To saying, hey, why don't we build a predictive model, based on future risks? We know which of these people are going to end up like in the hospital, build a predictive model to see this risk level. And then instead of outreaching everyone, do some randomization. And so what that means, and this is the randomized control trial, is holding back a small control group from any kind of intervention and just outreaching, the majority of the people with a small control group, and then seeing for those people that we outreach, did it actually work better than the people that were held back. So in a perfect world, that's how an RCT works. We live in the real world where there's not one program and there's overlap. So those
Right.
people that are held back are probably getting some other kind of treatment. So
Right.
it's kind of this incremental on top of whatever else they would have gotten. Is it better? So for us, we have that predictive analytics aspect, but we also need to be able to say, does this, whatever we're doing work, and is it worthwhile to keep doing? And so that's why we're trying to move towards RCTs, but it's complicated in healthcare.
Right. It's complicated because I would imagine not in the real world,
Yeah.
might be just a subset of what is actually going on in their world. And it's hard, right, to to work with an incomplete data set as a data scientist. Even when you know it's incomplete, it is difficult to work with it. So I imagine that's one of the big challenges. Is there any tips or tricks that you have that you found that work well?
I mean, that's why we're trying to do randomization, to
Yeah,
try to say, like, we know we don't have everything, but if we've randomized, we should be missing the same information for both groups.
right,
Does it always work? No. When you get into the nitty gritty of randomization with people, it gets really tough. So, like, if you're thinking about like a marketing campaign, so let's say I'm on the internet, I get an ad for a pair of pants. I'm like, oh, I like those pants. I click on it, right? From that perspective, it's really easy for them to be like, oh, we randomly chose Robin. We sent the pants to her. She clicked on it and bought the pants. You can really easily follow this through. When you talk about healthcare, so when we talk about our programs, it's not like a simple click through rate. So
right,
not only we have people involved in here, and so we have people that actually have to call up the members or the patient, and then we have to get them to agree. And to track that, you need a system to track that. So then that's an added complexity. Like, it's not like it's all in a single website where you can track and you can kind of see the transactional data. We don't have that because there's people involved in different steps and you have to track it. And
mm-hmm,
so it gets
mm-hmm.
really complicated, and there's a lot of places where the randomization can fail, and it's not anybody's fault, but you have to be really precise about where in the process you put the randomization into place.
So
So
what do you mean the randomization can fail? Like, what do you mean by that?
um so we, like I said, we have a lot of programs, and so let's say I have program A, and that's what I'm focused on. I want to know if program A works. That's where we're going to do the
Right.
randomization. Well, we also have program B, and some of the people that we would outreach for program A actually also qualify for program B, and we have hierarchies. And so program B actually gets a hierarchy. And so what that means is if they qualify for B, they get B over A.
Mm-hmm.
And so we would take them out of A and send them to B.
Right.
But if you just take everybody who's qualified for A and you randomize them at that point, they'll be balanced, but some of those people are going to fall out to B.
Right.
So it's actually better to wait, take A, take out the people that are going to go to B, then take that smaller sample and randomize at that point. Because
Right.
otherwise you're introducing this other bias where you might get
Yeah, once you start
unbalanced.
removing everybody who's participating
Yeah.
in B, and if they're participating in B for a specific reason, then you now have a bias. Sort of,
Yep.
it's no longer random.
Nope.
Your random your attempt at this random group of A folks as has now been sort of tainted, and it's no longer random. So yeah, that is certainly a big challenge, and I can imagine, like, from a complexity standpoint on your end, like there's not much you can do to say, like, hey, please don't let B trump A. Like, that's just, there's a business decision down the street, like downstream,
No
you have
control.
no control over. So yeah, that I can imagine that brings a whole host of challenges. Any tips or tricks on how to approach challenges like that?
Yeah, I mean, I think what I've learned so far, and honestly, this is something we're constantly working. There's always something new, but
Right.
really focusing. So I am all about program A. I need to understand the landscape. I can't just focus on A. I need to understand programs B, C, and D. I need to know what's happening there.
Right.
And I think sometimes that's hard. Like, you have people who are embedded in the business and they do understand everything, but you're just there to support them on A. And so they may not realize why you need to understand it all. And they probably don't even think about it, right? And so as data scientists, we really need to make sure that we're speaking up and being like, hey, I need to also understand if there's anything else going on, and then explain it to them why. And
Right.
I find, our business partners are like, oh yeah, of course we'll tell you that. Like, we want it all to work, right?
Right.
But if I didn't say anything, if I didn't know that was potentially an issue, they would know it's potentially an issue. And then you're 6 months into this randomization, and then you're like, oh no.
Right. So I think like the nugget there is to really understand as best you can the holistic experience that your member is undergoing. So what are all the like in an ideal world, you'd have this amazing, system that understood all the various touch points of that member, all the programs they were participating in, and then you were able to work with that downstream to better create your RCTs. So that seems in a way like there's a strong sort of data management challenge there in getting your data all prepped and like that. In the non-healthcare world, you talk about like that customer 360, right? You may talk about that in the retail world, in the marketing world, and I think it's what I'm hearing is it's really no different in the world of healthcare.
Yeah, 100%. Like we need this holistic view as much as we can. We want that 360 view. The problem becomes, if I am a retail site, I have one site where a person goes to, so I can track that.
Right.
You get into healthcare, there's different tools being used by different teams, different things are rolled out different ways. It gets really quite complicated. I don't know why that is. I think it's like, well, healthcare in general is like that, right?
It is absolutely. I've talked to a number of folks. It is healthcare in general. I mean, the systems there, I think we've all experienced it even on, every time we go to a doctor, we fill out the form again, and you're like, I just filled this out last time I was here.
I thought I told you this
wait
already.
to see if anything's changed. It's like, oh God, it is really crazy that is the case. But I think there's a lot of it could be wrong here, but there's a lot of sort of reluctance to share information because this is health information. This is information about me that is very private, and I think there's this this bent, and rightfully so, towards being as conservative as possible in terms of how making sure that the data is collected in an ethical way and all that, and making in a privacy conscious way.
Yeah, 100%. And then you have a lot of different players in the market, right? You have health insurance companies, which is where a lot of my data comes from. You have the actual doctor's offices who have their own data. You have hospitals that have theirs. And so, it's just complex. It's not me going into a store and buying a pair of pants.
Yeah.
It's
right.
I'm going to a single
all the
store.
data is being collected by that one retailer, and that's that.
Now,
when a retailer might say like, yes, they bought this pair of pants here, but they also bought, the top at the competing store, and I'd love to know that. Like, so if you're trying to understand truly like what Dave Cole likes to wear and understand my entire wardrobe, you'd have to collect data from a bunch of different places. I think the difference there is they're competing against each other, whereas in this world, you'd like for them not to compete, like for them to share the information because it's all about your and my health. That should be the most important thing. But I know there are certainly data and infrastructure challenges that you have to work through. That I think are relevant to all of us out there, right? Is like when you think about building out a data science team, like making sure that data quality and that data infrastructure and understanding your customer as best you can is really a prerequisite in most of the time. So.
Yeah, and it's probably something some of the newer data scientists don't want to hear. We spend a lot of time on our data to making sure I've been working with the same data for 5 years. Like I know it really well, and there are constantly new things I'm learning, and spend a lot of time on data quality, making sure that it's being pulled the same, the consistency. It's maybe not the most attractive part of the job for a lot of people, but it's the most important piece
There's
of
not
it.
A data scientist out there who's not nodding their head right now. They all
know
that's a big part. They all do it. They all know it's a big part of their job. And, I think there are a lot of companies who are trying to make that less like what a data scientist does, but it's that experimentation, that bringing, disparate data sets together to see if there are things that pop. That's just sort of the nature of the job. And it's hard to create that perfect system. I talked about the prerequisite. I'm sort of going back on what I just said. It's sort of hard to create that perfect system. um, as a data scientist, because you don't know what they're going to want to use in their next model, right? Even they don't.
Right.
Yeah.
Yeah.
Well, great. Let's switch gears a little bit. I know you wanted to talk.
Yeah.
We want to talk a little bit about product analytics. Like, what is product analytics? Let's just start there.
This is me being, I like this term. Um, I think for years, data science has been focused on predictive models, which is great.
Hmm.
But what happens after the model gets put into place? And so to me, this is where product analytics, this is what it means to me is you have some product or program that you're trying to sell or you're trying to promote or whatever it might be. You build a predictive model to figure out how to market to someone, how to target someone, timing, et cetera, things like that, which is where the field has been for years, is we need to build predictive models. And you can do it across disciplines for whatever reason. But we're starting to move just beyond that. And this is what I love. So the other half of that is, well, okay, we have this predictive model. We said this is the person we want to reach out to. Did it work? Did it do anything?
Right.
And, we just talked about RCTs. So in the best case, you could do really simple, like a t-test afterwards, if your randomization works. In healthcare, it doesn't work a lot. And so you can't just do a t-test to say whether or not things went well and our outreach actually worked. So this is where you have to bring in like causal inference, which is like my absolute joy. And where my team actually focuses a lot. So yeah, we have the predictive model, but did it actually work? And so I think data science is starting to move this direction. I know like Uber's doing some cool stuff with causal inference and some of the other big tech companies as well. And so to me, product analytics is this life cycle of predicting and then coming in on the back end to say, did it work?
Right. So predicting and then sort of testing on the back end to make sure it worked. And I would imagine also in healthcare, getting to ground truth is what you're talking about in terms of being very difficult. Like it's not always, like, hey, I sent them an ad and then I'm going to wait a month to see if they bought the pants. It could take months and months and months and months before that treatment is actually expected to take effect. Let's say, I don't know, but I imagine like it's not always immediate. And then also just getting the data set back to know whether or not it worked, just the practicality, like we were talking before, working with disparate systems, like also can be a challenge. Am I right on that?
You're right on that. So we're looking at behavior change, right? Like it's hard to measure. So do you know that somebody did it 100% because of what you did, or was there potentially something in there that confounded it? And so it's super interesting, but it's complicated.
Right.
And then on the back end for us, it's not about, well, sometimes it's about someone doing something. Sometimes it's about actually avoiding something. So we don't want people to end up in the hospital. You end up in the hospital means you're really sick, right? Like nobody wants that. And so a lot of what we do is, can we keep people healthier now so they don't end up in the hospital? So it's like down the road avoiding an event.
Right.
So you have to wait, right? And you don't know if what you're doing now is going to avoid something 3 months from now.
Right. So if the program is all about, I don't know, I'm going to throw this out here, Robin, just eating better, right? Like eating more vegetables, something I need to do. And that's to reduce your risk of heart disease. And you might have I might eat my vegetables and you might not. Neither of us may go to the hospital. So you don't really know if it's not like, I don't know. You could survey folks, I suppose, and say like, hey, are you actually following the program? How closely are you following the program? Not everyone answers surveys, right? And there's a lot of messiness in your world, it sounds like. Oh
yeah. Well, and then you talk about biologically, like all of us know somebody who's like the healthiest person we know, and they like get sick and you're like, whoa. They exercise, they eat right. They're not over here eating pizza for lunch like me. You're like, well, how did that happen? And because it's, we're talking about averages, and that person probably had some risk that we didn't have any information on. And so it's extremely messy. There's some really cool methods out there to deal with it. And it's
what are
an
some
area,
of those methods that you're excited about?
So this is an area one of the people on my team is like so good at this. He's awesome. So kind of moving into heterogeneous treatment effects. So not everybody is the same. We're not all homogeneous. And so within these populations and within these pockets, there's going to be people who respond better to interventions than others. And so using some of these methods to try to pinpoint who those pockets are, who are these people that will respond the best. And there's different methods for it. One of them is there's a causal forest. And so it's kind of like a random forest, but it's not exactly the same. So it kind of brings together the prediction piece with the causal inference. And it came out of Stanford, I believe. So they're doing a lot of really cool stuff in their econ area over there. So
cool.
Yeah,
Well, that's beyond my pay grade, but I mean that sounds that sounds interesting. I mean, certainly makes sense, right? That you would want to go after the folks who and focus more on the folks who are actually going to eat the vegetables than not eat the
vegetables and get the benefit from them, right?
And get the benefit. Yeah, there you go. Right.
So that's what it is. It's like maybe we have people that they can eat whatever they want and it doesn't matter. So we don't need to worry about them. But there's this group of people that, if they eat vegetables, then we can actually make them healthier. That's who we want to go after.
Got it.
Then there's a group of people that eat vegetables and they get worse. Who knows why, but we don't want to push vegetables on them.
Right. Gosh, there's your world is not for the faint of heart, Robin. But I think you are in the right spot. I mean, clearly, you sort of started your career wanting to help people, and you have not. That passion hasn't gone away, and you're just helping folks on a broader scale, and you're using data science to make that all happen. And I think along the way, I learned a few things from you about RCTs and also just how to go about working in the world of messy sort of data, and how to think holistically about your could be your customer, it could be your member. I think all of that makes a lot of sense, and there's some really good insight there. So I thank you for being on the DSL podcast. I've had a blast chatting with you, Robin.
Yeah, thank you. It's been fun.
Great. Well, have a great week. If people want to reach out to you and learn more, can they reach out to you via LinkedIn?
Yes, they can.
Great. Well, thanks again, Robin, and have a great rest of your week.
Thank you. You too.